course, software testing. So first topic is software testing fundamentals. So process of executing the software to find the errors. Okay, so that means you have to ensure the correctness, readability, quality. Verification means are we building the product right? Validation means are we building the right product? The main aim of the software testing is to deliver the defect-free system. That is defect-free software. So the process of executing the program with the intent of finding the errors. That is the software testing aim. So you have to ensure the software meets the requirements, or you have to find out the detect the or defect, find the errors early and improve the reliability and the quality of the project. So there are the two key aspects of the software testing. One is verification and another is the validation. So verification means you have to confirm the design or the specification. Validation means you ensure the product meets the user's requirements or the needs. That means you have to build the product right. Validation means building the right product. That is the software testing fundamentals. Software testing approach: black box test, white box test, regression test, level of testing, test coverage criteria. So black box means it shows only the functionality, and white box test it consider the internal logic. Regression test means you have to perform the retesting after the changes. Levels of testing means it's having the unit, integration, system acceptance, etc. So test coverage criteria means you have to fix the some condition if the condition is pass or failed based upon the coverage. And this is the shortest way of the black box testing, white box testing, regression and level of testing, and then coverage testing. So black box testing means you don't know the internal knowledge. You have to mainly focus on the input and output. So there are the two set of techniques. One is equivalence partition and another is a boundary value analysis. So black box testing means internal code is unknown. It with full and full depends upon the input and output only. So two main techniques. One is equivalence partitioning and boundary value analysis. So equivalence partitioning means how to divide the input into the valid or invalid class. That means partition. So test only one value from the each partition. That means it reduces the test cases. For example, age input field. The age is 18 to 60 means it is a valid. So less than 18 means it's invalid. Greater than 60 means it is invalid. Boundary value analysis means error often occur at the boundary limit. So you have to focus on the minimum, maximum, and just below and just above. So input range started from 1 to 100. So test the 0, 100, 101. Okay, so based upon the range. So equivalent partition means divide the input data into the partition. So each partition similar behavior. So only one value tested from each partition. So age input 18 to 16 means it's a valid. Above 60 or less than 18 means it's a invalid. So equivalence partitioning is a black box testing that divides the input data. Okay, so there are the two set, one is a valid and another is an invalid input. If you pick the one representative value from each partition, reduce the number of test cases, will maintain the good coverage. So key points, it's a functional testing. So reduce the number of test cases. So all the input in the same partition behaves similarly. So valid partition means it's a expected correct behavior. Invalid means error handling. Okay. So steps in the equivalence partitioning is: first you have to identify the input domain, that is the range or set of the possible input. Divide the input into the equivalence class based upon the valid and invalid. Select the one test cases from each class, execute and verify the system response. For example, age input field, age must be 18 to 60. So valid means 18 to 60, invalid less than 80, invalid greater than 60. So test case 25 means valid, 15 means invalid, 17 means invalid. So the password field, the password character must be 6 to 12. So 6 to 12 it's a valid, less than 6 character it's invalid, greater than 12 is a invalid. Okay, that is a equivalence partition. So advantage of this is reduce the test effort by eliminating the redundancy and both ensure the valid in invalid input scenario. So easily to apply the range based and categorized based input. But drawback is it does not cover the boundary condition. Okay, that is it does not cover the boundary condition. So boundary analysis is mainly focused on the boundary condition. So error often occurs at the limit. For example, I fix the range 1 to 100 means, so 1 to 100 is accepted. Less than 1 or greater than 100 means it's a range, not not valid. Okay, that means minimum and maximum value of the input range. So you have to pick the random input that may be minimum or maximum or just below minimum or just above maximum. Okay, so based on the conversion of error often occurs at the boundaries rather than in the center of the input range. So the range or the ordered set. So that means it's together with the equivalence partitioning. First of all, you have to identify the input domain and its boundary. Select the test case at below and above the boundary and execute and observe the system behavior. So age input field is 18 and 60. So 18 is the minimum, 60 is the maximum. So 17 is the just below minimum, 61 is just above maximum. Okay. Advantage edge case error, high effective handling the edge case error. Reduce the number of test cases, simple and easy to apply. But the drawback is not the entire input range. It cannot detect the error that occur away from the boundaries. White box testing means you have to know the knowledge of the internal code. So it mainly focus on the execution path, conditions, loops. Okay, so there are the basics two techniques. One is the basis path testing and data flow. So first technique is ensure all the independent paths are tested. So use the control flow graph or cyclomatic complexity formulas. That is vertex of edge equal to edge minus n plus 2. Okay, so the number of edge, number of node plus 2. That helps determine the number of test cases. Data flow testing means it's mainly focused on the variable. So ensure the correct data usage. Either the variable is defined or undefined or unused or improper modification. Test coverage is measure the completeness of the testing based upon the types, statement, branch, path, data flow. So regression testing means retesting after changes or the bugs. If any small changes means you have to perform the regression testing. That is a retesting. So ensure the modification don't break old features. So often automated Selenium J unit will be used to perform the testing process. For example, if the login fix retest login plus other modules you have to test. Levels of testing: unit test, integration test, system test, exception test. So unit test means testing individual module, testing the module interaction and entire system validation done by the end user. So unit test means a small testable part. That means you have to consider the each and every part of the system. That is a function, classes, etc. So it will be done by the developer, the tool JUnit and unit. So testing the login method, it tests the entire login method. So integration testing means module combined and tested. So detect interface issues. That means first you have to create the one module, second module, combine the both module, you have to perform the integration. After integrated, it will be any fault or error will be arised in this. So based upon the approach, bottom up, bottom down, that is bottom up, top down and big bang. So system testing means the entire system tested as a whole. So it's validate against the requirements. So based upon the performance test, security test, usability testing. So acceptance test means it will fully conducted by the end user. Okay, there are the two set of tests that fully depend based on the requirements. One is alpha test, that is a developer side, and beta test, that is a user side, that is a customer side. That's all about the unit 4.